Hello everyone, welcome to my presentation. My name is Yan-Ling. I'm currently a master at National Taipei University of Technology. I'm very pleased to have this chance to give this presentation. The name of our list is Influenza-Like Illness Patient Forecasting by Fusing Internet Public Update. The outbreak of COVID-19 at the end of 2019 has spread around the world at a rapid pace, revealing the pandemic infectious disease that harm, causing mass influenza in the past, have become a major concern in modern society. Influenza-like illness refers to any virus that causes symptoms of same severity as influenza virus. In order to understand the state of influenza-like illness outbreak in real time, so we propose a complex method that uses multiple datasets as feature to predict influenza-like illness in Taiwan by machine learning. The most important part of predict influenza is selection of features, so we focus on selection of features. First one, NEC run adult experiment with guinea pig has confirmed that the relative humidity and temperature of an environment have a strong influence on the spread of influenza virus. We should also investigate the patient relationship between air pollution and influenza-like illness in Jinan, and found that PM2.5, PM10, and SO2 show potential related effect with influenza-like illness of peak time. We use the required dataset, processing the data according to different datasets, and merge the processed data together. The merged data is divided into training data and test data. And the training data is fed in XGBooster, random forest, and SVR to train the model. The final prediction results are output by ensemble learning. Finally, the test data is used to validate the prediction model. There are features used in our research. Hydrological and meteorological data, air quality data, etc. do not always show the impact on influenza visited on the same day, and may lag behind by a week or more. Therefore, when the target week is determined, the data from the period last week will used to input the target weeks for the prediction of influenza. As in the table, that week 13 is the target week, and the data of week 20 is fed into the target week for prediction. Influenza-like illness is cyclic pattern. The year and number of weeks are encoded with 100 encoding, which is used to represent the cyclic factor, and there are this year from 2016 to 2021, which 52 or 53 weeks in a year. In research, XGBoost, SVR, and random forest were used for training model, and then I will introduce three models. XGBoost based on extension of improvement of Gideon booster tree. The original model can be written, and the model can add new functions to adjust the error of the previous tree for classification and regression problem. SVR is intention of SVN that can handle continuous prediction problem. Random forest a competition of decision tree classified, where each classified is independently sampled from random vector of input vector. Bagging algorithm is used for each vector or vector combination. Like random samples are taken from the training data to training multiple classifiers. Lastly, in the case of classification, which are used to vote for regression, the results are often using averaging method. This study used two evaluation indicators, RMSLE and R-squared. RMSLE is the log form of RMSE, which also considers the relative error like MSPE and MAPE, but it is error curve has its symmetry. R-squared evaluated the degree of explanation of change caused by the variable y and the regression model, and it is also audited to evaluate the goodness of the regression model. In our study, we use 7 datasets and select 19 features for training. The 7 datasets contain hydrological and meteorological data, statistics of emergency infectious disease surveillance, Influenza-Like illness data, Google Trend, public holiday in Taiwan, air quality index, population and population density. This is evaluation of our training module. From the table, we can know that both XGBoost and random forest are better than SVR. SVR was less effect, so SVR not including the final prediction result. We perform ensemble learning using the prediction result of XGBoost and IF random forest. The green line is the prediction result of ensemble learning, and the purple line is actual number of Influenza-Like illness. We use two varieties of data for model training and prediction of Influenza-Like illness. Prediction of the number of influenza of illness will allow the authorities to quickly understand and state of influenza-like illness, infection, and make related correct decisions and preventive measures. Thank you for listening.